It's about to start.
Start.
Wait for it. Okay, we're live.
Oh, hey, yo, we're live. Hey, what's up? Hey, hello, world. Okay. All right. So, actually, let's be real for a second. I actually do my job, you know. So, again, I'm Mr. Woods. Of course, y'all know me, and hopefully y'all just got little introductions, okay? I've been told I'm like the worst teacher ever. Yeah, y'all kids are mean. But look, I'm going to try to prove y'all wrong today, okay? I promise, okay? I promise I'm going to try to prove y'all wrong, okay? So, my job is to teach y'all triangle congruence in like 40 minutes. Y'all ready for this? Okay, but I promise I'm going to make it so easy for y'all. You're going to be like, what? I'm like, yes. Okay, triangle congruence, okay? Let's see y'all remember a little something. What does the S usually mean when it comes to triangles? What does that usually mean for y'all? Side. Yeah, beautiful. What does the A usually mean? Angle. Okay, it's good. So we start to remember this a little bit, right? So two triangles are congruent and all their sides are congruent. You would say that's a what? Side, side, side. Yeah, SSS, right? Easy as that, right? Sounds good so far? Okay, now, on your paper, on your front cover of your paper, where you see HL, I want y'all to put a star next to that one. What's up? Oh, Jack. No, I gotta get paid for.
Oh, is that okay with her?
Here you go. I skipped you, didn't I?
No, I just.
Oh, you just came. Well, hello. All right. Well, here, guys, put a star in HL for me, okay? Put a star in HL. The reason why I want you guys to put a star in HL because it's a special case, okay? Now, it stands for hypotenuse and leg. What is the only triangle you guys know that has hypotenuse and leg in it? A right triangle, right? So you only use HL when you have a right angle and the hypotenuse and the leg of both triangles are congruent, okay? Make sure you guys understand that. That's why I want y'all to put a star. Make sure y'all understand that. Does everyone understand HL a little bit? Sounds good? Yeah. Okay. Yeah. All right. Flip your paper over real quick. Flip your paper over to question number 1 real quick. See, I'm going to flip mine to the low angle. Okay? So, question 1. Okay, I want to make sure I go right here as well. Don't judge my drawing. I'm not the best drawer. I didn't go draw in school. And I'm pretty sure every teacher is not the best drawer, but let's try to do good here. And that's an E. That's an A. All right, so guys, let's go ahead and get a different marker real quick. I'm a different marker type of guy. You know, I like to use different colors. I don't like using the same color every time. All right, so I'm going to use green here, okay? All right, so guys, when you look at a question, what's the most important thing you got to do when you look at a question?
Find what you want to answer.
Yeah, but what's the other one? It's super easy. You gotta read it, right? You gotta read the question. Because guys, if you read the question, you might get what out of it? Answers, right? And that's what some of these questions are super easy to get some answers, right? So let's read the question. Question 1 says, consider the two triangles right here, okay? These are two triangles. It says, given R is the midpoint of AG and ET. Now, let's pause that for a second. What does midpoint mean to y'all? What does it mean to y'all? Middle. Okay, what does middle mean to y'all, though?
If there's 2 points, you cut it in half.
Oh, that's what I was looking for. You cut it in half, right? Yeah, it means middle, but it means cut it in half, right? So based off our directions, R is the midpoint of A, G, E, T. So that means R cut A to G in what? And what, guys? Half, right? So that means G to R should be what to R to A? Congruent is the word I'm looking for. Good. And that means R cut E and T in half, right? So that means from T to R, it should be what to R to E? It should be the same or different? Should be the same, right? Congruent. Boom. Guys, make sure y'all mark this up on your paper too, right? Y'all got paper copies for that. Okay. So now, that's based off the direction. So now you guys can work on your problem. Okay? Now you can set yourself up for success. All right, number 1. Yeah. Oh, excuse me. We're looking at question 1, right under the bottom where it says statement 1, okay? So statement number 1, R is the midpoint AG and RET. Why is the reason given? Why are they telling the reasons given? Why is that? Because they told us, they gave it to us, right? And we got that based off reading that directions, right? So now look at number 2 and 3. It says statement 2 and 3 is blank, but they say the reasons definition of midpoint. So what does that mean, y'all? I got y'all though. Definition of midpoint basically means I need you guys to express to me, aka show me, how is R the midpoint from A to G. As in, if I were to write something out to show me this relationship, how do I write it out?
GR is equal to AR.
Right, I can say GR, okay, and AR. They're not equal per se, but what's the word I gotta use here? Congruent. And what's the symbol for congruent?
The equal sign with the squiggly line.
Yeah, equal sign with squiggly line, right? So guys, this right here is definition of midpoint. Okay, and again, that's your second block right there, right? That's your number 2 for your statement, right? So you're right, GR is congruent to AR. What this saying, you guys are expressing that R is the midpoint of A to G and then cut it in half. That's what you're saying when you express that, okay? So now, let's look at number 3. Number 3 says definition of midpoint again. So based off your segment, R is the midpoint of E to T, how can I express that to show that R cut ET in half? How can I express that? Oh, look at y'all using good vocab. Y'all getting all the good things. I love it. I love it. I love it. Good job, guys. And again, this means definition of midpoint, right? You are expressing that. You're expressing that R is the midpoint from E and T, and that cut into 2 equal pieces, okay? All right. So now, that was 2, that's 3, right? Let's look at 4. Angle GRT is congruent to ARE. First of all, do you guys see angle GRT here? Yes, right here, right? Y'all see that, right? Yeah? Okay, it's right here. Boom. Okay, do you guys see angle ARE? Yeah, right here. Okay, what is, now, they told you they're congruent. They want you guys to tell them why they're congruent. So why are these 2 angles congruent? Vertical angles. How do you know these are vertical angles, by the way? Cross each other. What's another reason?
The midpoint of both of the lines.
Yep. R is the midpoint of both those lines. What's another indicator for y'all?
They share a point.
They share a point. What's another indicator for y'all?
I can see it.
You just, how can you see it?
Because
Mix and egg.
they're adjacent.
They're adjacent here. Oh, I like that word, adjacent. Okay, what else we got though? I'm gonna give y'all an easier way. Y'all ready for this one?
They're B and an A.
Yeah, but what shape does this make right here?
Just a big X.
An X. And let me tell y'all probably won't write this down, right? Anytime y'all guys see an X, that's vertical angles. Anytime y'all see an X, that's vertical angles. So make sure y'all write that down somewhere, right? That's an important note you guys want to write down somewhere. Anytime you guys see an X, you get vertical angles. And what does that mean? Vertical angles means this. The top matches the bottom, the left matches right. So angle 1 equals angle 2, 3 equals 4. Okay, just for my example here. Okay? Vertical angles. Okay? So these 2 angles, GRT and ARE, they're congruent because why again? What's the reason between them? Vertical angles. Now, this is off-topic question. If you were to add all 4 of those angles, how much do they equal? If you were to add all 4, 360. Good. Don't forget that. So don't forget, you add all 4 of these up, and you were to add all angles to give you 360. Right? If you were to add all 4 of these angles, you get 360. Sounds good? Okay. So again, for number 4, the reason why these 2 angles are congruent is vertical angles. Now, let's look at number 5. Ooh, number 5 is my favorite one. And now, all you gotta do here is the easiest part. Based off what you have drawn up, and based off your 5 choices, which one of these 5 choices matches up with what you have here? Which one you say? Side, angle, side. Yeah. And guys, that's simple, right? You have a side and a side. You have an angle and an angle. And a side and a side. Spells out for you, right? SAS. SAS. See, I can't pronounce it right. Okay? Does everybody understand question 1 real quick? Does everybody understand definition of midpoint a little bit better now? Okay, does everybody understand vertical angles real quick? Does anyone have any questions? All right, and we move on then. See? Easy peasy and sweet. All right, guys, I'm going to skip number 2 real quick because number 2 is a little lengthy one. We're gonna say that for last, so because number 2 is gonna blow your minds out a little bit. So now let's do number 3 though. So skip 2, go 3 for me. We're gonna skip 2, go 3. Okay, I'm gonna try to draw this up, so please forgive me. Again, not Picasso. Oh God, this is ugly. This is really ugly. All right, so that's number 3. That's your picture drawn up, looking beautiful, right? Okay, so again, what's the first thing you guys gotta do when y'all see a math question? You gotta do what? Read directions, right? So let's read them. Consider these 2 triangles are in the diagram below. Okay, that's awesome. It says given angle N and A are right angles. So they gave that to y'all. Then they say I is the midpoint of PT. All right, so based off that, we start doing some things, right? So I is the midpoint of PT, which means to cut PT in what now? Half. So that means this piece should be what to this piece? Equal or different? Equal, right? So we can put a little tick mark there, right? All right, what else? Yeah, okay, so what else do you guys see from this picture here? That you can make an assumption out here. Okay, ooh, that's actually pretty good. I love that. Okay, give me something else though. I want to do something what's going on here. Nope, can't say. Vertical angles, good. Okay, and why are these 2 angles vertical angles? Because you see a what shape? An X. That's simple, right? Okay, so this is vertical angles. So again, based off directions, you can say that TI, PT got cut in half equally, and you can say like, hey, I got vertical angles here as well. And that's all you can say. You don't know that I is the midpoint NA. So you can't say NI is equal to IA. You can't say that. Okay, they didn't tell you that. You can't assume it. Okay, so now let's look at number 1. Again, question 3, statement 1. Angle N and angle A are right angles. It's given, right? Because it was in the what, guys? Question. Yep, I like it. It was in the question directions, right? Now, number 2. Here's number 2. Angle N is congruent to angle A. Why is angle N congruent to angle A, you think?
Thank you, sir.
They're what?
Uh-huh.
Oh, what's up? The definition of right angles, yeah. So guys, so number 2, the reason why angle N is congruent to angle A is a definition of right angles. Okay, make sure you write that down for your reason, right? Make sure you write that down. Okay, so for number 2, the reason why N and A are congruent is called the definition of right angles. Meaning, if they're telling you that they're right angles, they equal 90 degrees, which means they're automatically going to be congruent. Okay, so now let's go to number 3. I is the midpoint of PT. It says given, because obviously it was giving us in directions, right? Okay, so now look at 4. 4 came up, something we just went over. Definition of a midpoint. What's the statement I'm going to write there? What's my little statement I'm going to write to express it? Yeah, PI, or I'm going to write TI is what to PI? Equal or congruent? Congruent to IP or PI, right? And this is your, again, this is for question number 4 here. And this is your definition of a midpoint, right? This is how you express it. So now, let's look at 5. 5 said angle TIN is congruent to AIP. What's the relationship between these 2 angles again? Vertical angles. So good. Make sure you write that down for 5, right? So 5 is vertical angles. These 2 angles, TIN and AIP, are congruent because of vertical angles. And what lets you know they're vertical angles again? What shape? You need to see an X, right? I told you, every time I see an X, it's probably going to happen. All right. Now, number 6. Number 6 says, based on what you see right now, which one of these 5 choices makes these 2 triangles congruent? Which one y'all thinking?
Angle side.
Angle side, yeah, AS, right? It'd be an AS. How do you know it's AS? Well, let's go through it, right? You have an angle and an angle. And you have an angle and an angle. You have a side with a side. AAS. Okay? AAS. Right in that order, okay? Okay, so far so good, guys? Okay, so now, number 7. I like this question. Number 7. Why do you guys think NI is congruent to AI? Why do you think that?
Definition of congruence.
Definition of congruency. Explain that to me. What does that mean to you?
Both triangles are congruent. That means the sides have to be congruent. Like those 2 the same, and if they're the same, that means I is the midpoint.
Ooh, nice. So guys, let me just rephrase that for y'all. This is the word you're gonna see when you see it. I like how you were thinking. Okay, everybody, in front of the paper, you might want to write this down, or in the bottom right here in the corner. You might want to write down C P C T C. Write that down. C P C T C. Okay. If you want the long version, here we go. I catch my breath. I'm gonna write it out for y'all too. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Whew. There we go. CPCTC. By the way, this is for number 7 as well. This is for number 7. The reason why you guys can say that NI are congruent is because, and I like to use this little saying to have like a little cheat sheet. You use CPCTC after you solve for triangle congruency. Use this after the fact. So like my man said, he said, well, we figured out the triangles are congruent, so that means the other parts got to be congruent because we just figured out the triangles are congruent. That makes sense. So after the fact, so after you guys figure out your triangle is congruent from 1 of the 5 choices, anything after that is CPCTC, corresponding parts. We're going to assume they're congruent because the triangle's congruent, okay? Does everybody understand what that word means? Okay? You will see this word a lot, so make sure you guys understand that. Y'all good with that, guys? Any questions? We're good so far? All right, let's move on now. I like it. Guys, y'all all good. Good job. I gave y'all a round of applause, but my hands are full. So I'll give y'all, let's see my voice crack. I got my long arms. Look at that. All right, so now let's look at number 4. Let's look at question 4, all right? Guys, do me a favor. Circle question 4 for me. Like, put like a star circle there. Because that's a shape you guys have to kind of get familiar with a little bit. Obviously, we see that a lot. I know y'all seen that a lot somewhere. So make sure y'all just get familiar with that shape. That go right, yeah. Ooh. All right, just a brainstorm real quick. What kind of shape is this? Just a brainstorm. I say it. Not quadrat. It's a quadrat, but what is it though? A parallelogram, right? So where do y'all go? Parallelogram, right? It's a parallelogram, right? So guys, just want to catch up on y'all, make sure y'all know what shape that was. That's all. Okay. All right, that's it. I'm messing y'all. All right, parallelogram. Beautiful. Okay. So again, we're gonna make sure we read directions here. Okay. Always make sure y'all read here. Read. Read is important. So now, OH. Let's make sure again. Given OH is parallel to EP. EH is parallel to OP. Okay. So that's given to y'all, which again, how do you show that lines are parallel again? How you show it? How can I show this line is parallel to this line? With the little caret arrow sign, right? Okay, so make sure, guys, if you see this, don't freak out. Does this mean that they're congruent though? No. Make sure you understand that, right? Make sure you understand that these two things are not congruent. They're just parallel. Which means, do they touch each other? Never, right? They'll never touch each other, right? Never, ever. Okay. So now, let's look here. Number 1, statement 1. OH is parallel EP says given. Obviously, it's given to you, right? So now, look at number 2. Number 2 says alternate interior angles. What is alternate interior angles to you guys? What is that to you guys? What do y'all remember anything from alternate interior angles? What's up? Come on, someone say it. What, opposite? Or opposite? What does that mean, though? Let's elaborate on that real quick. Brainstorm it. What y'all got? What we got?
So it would be like PHE
Mm-hmm.
and HPO.
Oh my God, yeah. Nice. I like that. Good. So guys, let's expand on that, okay? I'm gonna give y'all a hint, and y'all gonna be like, y'all gonna use this every time. Watch this. What shape is that?
Z.
A Z. Here's my hint to y'all. Anytime y'all see a Z, you're gonna have alternate interior angles. Make sure I write that down somewhere. That will save y'all a lot less stress. So that means, what that means to me, and like I tell my other kids, is that if you can trace a Z, you have alternate interior angles. That's the relationship right there, okay? if you trace an N, it's alternate interior angle. So Z, or you even have an N. So Z or N, you get alternate interior angles, right? Zen. Boom. Okay? Ooh. What? Y'all heard that? No.
Oh,
Okay, you missed that. All right. So again, alternate interior angles. So now, look at number 2. It says blank is a statement, but the reason alternate angles. So now, this is what we're going to do. Again, we're focusing on OH and EP. So like, again, I like to draw things, which again, make sure you guys stay drawing stuff. I like to draw stuff. So if this is OH, this is EP. They're parallel, correct? All right. I'm going to draw a line right here. Okay? What shape is this made again? A Z. So you have alternate angles. What's the name of this? Excuse me. What's the name of this angle right here? OHP. Good. So angle OHP is congruent to what's the angle down here? EPH. Okay. Now I'm gonna blow your minds out real quick with this one. Why did I call this EPH and not HPE? Why did they call it EPH and not HPE? Why do you think?
Because that goes in the direction of
Give me something else.
on the top was like.
They won't arc off on the test.
They won't.
Nope, they won't.
They won't.
It's a, just so you know, because I would do it either way.
Yeah. Yeah. So guys, either way, okay, I'm just messing up, okay? Yes, HPE is still the same as EPH though, okay? But again, like because I'm gonna tell you how I'm thinking because I'm crazy, right? Okay, I'm thinking that if I call this OHP and OH and EP are parallel, they gotta be in the same position.
Oh, yeah.
That's how I think of it, right? That's how I think of it, right? So if I call this HPE, in my head, I'm saying, well, HP is the same as OH, which is not. They ain't the set, right? So I think of this as OH is parallel to EP, which means wherever you are, I'm there too, because we gotta be in the same direction. That makes sense to y'all? That's the way I think. Now, you call it HPE if you want, and you still be right. Again, I just think crazy like that, okay? So, this is for answer number 2, by the way. Y'all figured it out yet, right? Answer number 2. Okay, so now, let's look at number 3. EH is parallel to OP, it says given, correct? So do we need to really do anything there? No. So number 4, okay? PHE is congruent to HPO. Again, I like to draw things out. So let's draw this out real quick. PHE. Right? This angle right here is congruent to HPO. Okay? What shape is that form right there? An N. And what did we just say? If you have a Z or an N, you get what? Interior angles. So the reason why these two angles are congruent is because what's the relationship between them again? I know. I mean, y'all say like 4 times in a row so far, right? Alternate interior angles. What's up? Sure. Okay. All right. So there we go. Again, this is for question. Again, they're alternate interior angles. The relationship between these two angles, number 4, is alternate interior angles. So now number 5, reflex property. Oh, this is my favorite one. What does reflex property mean to y'all? Yeah, it's the same line that acts as a mirror to 2 shapes, okay? So guys, when you see reflexive, think reflect. And you guys have something in your bathrooms, they have brush your teeth, always looking at what? Mirror, right? And it reflects back at y'all, right? So based off your shape here, what's the segment that's acting as its mirror? HP, right? It's acting as a mirror. Because if you were to fold this up, you get a quesadilla. See? Quesadilla. See, I told you I got jokes. Dad jokes. So. Okay? So HP. How can I express that HP is like reflecting itself? HP is not equal, but what? Congruent to HP, right? So HP is congruent to HP. Or you guys might see it sometimes HP congruent to PH. You might see it like that too sometimes. Don't get confused. Okay? This is called a reflex property. This is for question number 5, by the way. This is 5. This is called a reflexive property. I can't spell, so don't judge. Okay? So now, that means it's congruent here to both triangles. So now, the last part, which is the easiest part. Based on what you got, Which one of these five belong there? Angle, side, angle. Good job. Again, angle, angle, side, side, angle, angle. Right? Spells out for y'all. Sounds good? Okay. You guys have any questions for me real quick? Anything? You good? Are we all comfortable with reflex property? Are we all comfortable with alternating interior angles? All right. So that means I'm doing okay then, guys. All right. That means I'm not getting tired yet. Not yet. Okay. Y'all helping me out though. Good job though. Y'all good. Okay. Are y'all having a good day so far? All good so far? Guys, guess what day it is? It's just Wednesday. You know what that means?
What is that?
It's hump day. That's my favorite day. Hump day. All right, question 5 real quick. All right, so everybody do question 5 real quick. All right, 5. Okay. Again, I love question 5. Question 5 is my favorite question. I don't know why. Okay. Again, what's the first thing you should do when you look at a question? Read. Okay. So let's read the question. It says, again, these are two triangles below. It says, given CE is congruent to AC, right? So we know that's true. And they say ER is congruent to AR, right? No, that's true. So now, if you look at your proof, which again is called proofs, right? CE congruent to AC is given. ER is congruent to AR is given, right? The first two are given to you based off directions. So now, number 3, blank reflex property. Uh-oh, we just went over this. What is a reflex property? Yeah, look at this picture. What's the reflex property here? Yeah, I'm hearing all the answers here. You got CR is congruent to, again, RC, or you guys might see it as CR again. You might see it as reflected to both sides, right? So, that's called your reflexive property. Just rewrite it for y'all. It's called your reflexive property. That's how you write it. That's how you express it. And that's question number 3. Now, here's a real question. How can I mark this up? I want to mark it. How many ticks does it get? It's 3. Why not 1?
Because it's not the first.
Yeah, it doesn't go with these. Why not 2? It doesn't go with these, right? So the next number after 1 and 2 gotta be 3, right? So just make sure I remember that, okay? So now, based off your choices here, which one of those 5 does this belong to? Yep, set aside. The one that everybody wants to answer so fast for. Set aside. All right, how fast can I say? Okay, S, and then S and S, right? Side. Sounds good? You guys have any question number 5 real quick? Y'all good? All right, so now, we're going to skip 6. We're going back to 6, but I want to stay on this topic of side, because let's go number 7 real quick. So I'm going to go back to 6, don't worry. We're going right back to 6 after 7, don't worry. I just like to skip around, because who likes to go in order? 7. Okay, look at 7. I'm going to draw this picture up. Again, excuse my drawing. Ooh.
You know.
Yeah, it's not my best, but it'll do. I can do better. I'll do better next time. Guys, I've been practicing this for like 4 days now. I still can't draw. So, I'm not Picasso. Is that how you say his name, by the way? Is it Picasso or Picasso? Picasso. What? Picasso. Okay. I keep saying, okay, my wife's also an English major, and she be correcting me every time she can. Okay. So, if you look at question 7, by the way, once y'all guys look at 7, who believes this was a hard question? Raise your hand right now. Do any of y'all think this is a hard question right now? Raise your hand, be honest with me. No? Most of y'all feel good about 7? All right, good. All right, hey, I got to get my responses. I heard kids say they looked at this and they said, we ain't doing it today, boss. I was like, all right, you're right. Let's do this, okay? So, let's read directions, though. Find the values of X and Y and prove that these two triangles are congruent by SSS. So, what is that telling y'all? That these two triangles are what already? Congruent by what? By which one?
Like we did 5.
That by SSS, right? So what does that mean? That means this piece should be equal to what? 1 or 2? 1, right? This piece should be equal to who? 1 or 2? 2. And then this middle line is called a what line again? Yeah, woo, look at y'all using big words on me. Okay? So this is your side. This is how they got side, by the way. This is how they got it. Okay? A lot of kids struggle knowing like where they get it. So if you know how they get it, you guys can do math really easy. Okay? So now, how can I solve for y here? What can I solve for y? How can I solve? What's my equation I can set up? Oh, dang, y'all are so quick with it. I love it. All right, you guys know math. How can I get y by itself? Yeah, what's 4 plus 12? Yeah, and you're done, right? You're done. That's it. Super easy math, right? Not a scary question no more. All right, just look at it again. You got to solve for x, though. What's my equation for x real quick? Woo! Y'all, boy, I love the competition. See who gets the answer out first. I like that, though. Okay. All right, here's a nice question here. What can I do here? What's up? Ooh, let's talk about that one. All right, guys, you know my rule is in my class? You want to move small numbers to big numbers, not big numbers to small numbers. Ooh, or we can do that too, right? So there's many ways to do this problem, right? You can minus x on both sides, or we can move the 7 over the 3. Now, for those that said 3 to 7, I know why you did it, because 7 is a bigger number than 3. But who's technically bigger? Is negative 3 closer to 0 than negative 7?
Yeah, negative 3 is close.
Yeah, negative 3 is closer to 0 than negative 7, right? Like if you were in debt, it's easier to make up $3 than it is to make up $7, right? So you can take either route. You can say minus x on both sides. You can say plus 7 on both sides. I'm gonna add 7 on both sides to make it easy for us, okay? So I'm gonna add 7. So x, what's minus 3 plus 7? Plus 4. Yes, plus 4, right? Because the signs are different, so you subtract 7 minus 3, keep the sign a bigger number. Plus, right? Equals to x. Now what can I do here? Minus x. Guys, what is that called when I move something from right to left and move something from left to right? What's that called? What am I doing to my equation? I'm making sure it's what? Not equal. What's the B word? Looking for a B word. Balance, right? It's called balancing your equation. Right? I can't move two things from one side and expect my equation to still be working, right? Whenever I gotta move one to right to left, and gotta move something left to right. So I'm gonna minus my x here. My x's gotta stay with each other. So 4 equals is 2 minus x. X. It's x. That's the answer. Okay? You guys have any questions on number 7?
Would we have to plug them in?
No, you don't have to plug them in. You can plug them in to check your answer if you like to, but you do not have to plug them in. All they're asking you solve for x and y, which you did, okay? But if you want to plug them in to make sure you're right, please do so, right? Okay. Nice job. All right, last one we got. Okay, I think I got time for one more. Depending how smart you guys are. I think I got time for one more. Right? What time y'all leave again?
5 minutes.
Oh, I got 5 minutes, guys. Guys, we can do a lot in 5 minutes. Number 6, all right? I'm going to do number 6 here. Let's see if I get my drawing here skills. This is my one last time doing this. That was terrible. I'm getting better at this, though. All right, last one, guys. Again, just hold out for me for this last question here, okay? I know y'all ready to go. Hold out for me, though, okay? Now, again, we have to find the values x and y, right? And it says the two triangles are congruent by AAS. So now the hardest part is just knowing, like, where is the AAS coming from, right? Where is it coming from? Well, guys, you guys are smart right here. You guys know here is what kind of relationship here these two things share? Vertical angles. So that means, okay, that's one A. So the other A has to come from here, right? So AD should be equal to who? Yeah, that's the other A, right? So A, and then here's your S, right? 17 is going to equal 13 x minus 9. So there's your AAS right there. So now let's do math, right? We all can do math here. How can I solve for y real quick? How can I solve for y?
7y minus 4 equals 80 minus, add 4 to both sides, divide by 7.
Ooh!
Y.
Ooh! God damn, hold on. Ooh! Ooh, look at you. I'm trying to keep up too. You went out. That's on me. I ain't gonna. I know. I just go too slow. That's the problem. But hey, man, I'm a slow guy. Hey, the turtle wins the race and the rabbit. I remember that now. Mm-hmm. Now look, see, I went fast. Look what I had my egg out looking ugly. See, I don't like that. Look at it. Yeah, like she said though, 7y minus 4 equals 80. You add 4 on both sides, get 7y equals 84. You guys know the 5 by 7, get y by itself, 84 divided by 7 is 12. If you got a calculator, put in your calculator. If you can do it in your head, do it in your head, right? Think, last one we got to do somewhere is x, right? I got set for x. What's the equation for that one?
13x minus
Oh, she went backwards on me. Oh, God. Guys, this is the same way that I would have done the other way, too, by the way. All right, what should I do here?
add 9 both sides.
Add 9 both sides. So now what does that equal? 17 plus 9?
26.
26, the same age I am.
Divide
Divide by 13, and what we get?
by 3.
X equals 2. Ooh, yeah. Boom. Oh, that's a nice 2, too. All right. Guys, are 6 and 7. Y'all good with that one? All right. Okay, do you guys have any questions on the math or anything like that? Y'all good? Okay. All right. Guys, do me a favor, though, real quick. Y'all got to do me a huge favor. Go number 2 real quick, because that's on me. Okay? I say it for life, because it is a monster question. Circle number 2, and literally write down and say, hey, Miss O'Connor, can you go over this question number 2? It deals with transformations, and Mr. Woods had no time, because you work slow. Okay, make sure you let her remind me that I can get with her to help y'all out, okay? That's my fault. Okay?
If you could go ahead and teach it for the video, and guys, when the bell rings, you're free to go.
Yeah.
Okay?
Okay. Don't worry about that, okay?
Thank you. Good job, you all.
Good job, guys. Y'all get ready to go, though.
Like I said,
All right. Go ahead.
no, it's fine. I'm not worried about it. It's just, it's different every class and it's different classroom. So, but thank you for your help. I really appreciate it. My question was, the problem, I think there's something like that. I just want to know for sure. I want to see that you sleep tonight, right? Am I looking here? No, it's still rotating. Wow, you all great work, everyone.
Okay.
Thank you all.
My bad. I gotta make sure I get grabbed.
Take your time.
Okay. So I gotta draw. That's not right drawing, right? Just wanna make sure. All right. All right.
The one on the right is a little smaller.
Is it small?
Yeah. He's recording.
Yeah.
We're just, no, it's okay, come on in.
Yeah, come on.
Yeah, you know.
You wanna?
Yeah, that looks small.
It looks small, right?
Yeah.
I can't read. I
You
don't
want
know.
me to help you?
Yeah, I just can't. I can't see.
You're at,
I'm bad.
4, 2. This copy came out
So
horrible.
this is 4-2.
And so, is that right?
Yeah.
4, 2, and then we have 5, 4. And then we have 2, 7. 2, 7. That's that the same thing you just did?
Yeah.
That's not on the right, okay?
I gotta make sure I can't see something.
4, 2, 4, 2.
Yeah.
So let's do this. One, 3, no. Alright, you know what we can do? Let me just pull it up real quick.
Okay.
Hola! Sorry. See here. Oh, here we go.
There you go. How'd it go?
Alright.
I mean, I had a lot of them.
We're recording right now. Where do you know?
You're okay.
Yeah.
Did you get my message?
Alright, so this is at 4, F is at 4, 2,
Oh.
G is at 6, 4. That's the mess up right there.
Okay, so F is at 4, 2.
4, 2,
G is at 6, 4.
6, 4, and then E is at 2, 7.
1, 2, 3, 4, 5, 6, 7.
Does that change? Is that the same thing?
And then A.
Perez, I'll come over in a little
And
bit.
then A is at where again? And A is at where?
A is at negative. Oh my goodness gracious. Hold please.
Me too, that's what I said.
A is at negative 5, 7.
Okay.
B is at negative 3, 5. C is at negative 9.
All right.
Is that better?
Yeah.
All right. Oh, that's it. There she is.
Yeah.
Good job.
All right. And this is a problem of rotation and translation, right? Okay. All right. So if I were to do this problem, okay, A's at, I'm gonna make sure I get my points right here. I like to write down my points.
What does the question ask again?
I think to justify how the triangle ABC get the triangle GE.
Gotcha.
I think that's the question. Yeah, how you prove it? Find that
Yeah.
this transformation, right? Okay. So again, I like to write all my points, okay? Because again, I can find 1 point. Again, this question gets very confusing because a lot of kids will try to try to do every single point here. Reality, you just need to find one. You can find one, you can find all, right? So I'm gonna do the easiest point for me that I can see right now. Right now, the easiest point for me right now is gonna be B. So I'm gonna say it's 1, 2, 3, 1, 2, 3, 4, 5. So B is at 3 and 5. Again, remember when you do your points, it's always the X first, then the Y, not Y then X. Okay. I got to put parentheses. I'm sorry about that. There we go. Now I'm good. Okay. So now, when we're thinking about this, right? So we're thinking about our triangle. They're saying triangle ABC should be congruent to, again, I just want to make sure I'm right here, is GFE. GFE. Okay? They're saying these two triangles are congruent. So what does that also mean here, though? We're looking at this. That means B corresponds with F. Okay? B and F correspond with each other. Okay? So B corresponds with F. Okay? Which F is the same thing as saying B prime. That's something you guys gotta be aware of, right? F is B prime. Again, to know that prime is a symbol for transformations, which you all should remember, you indicate with a little semicolon, right? So again, B is F, which is again, F is B prime. Let's not forget that. So now you're probably looking at this picture here, probably like, wow, how did it get here all the way to here? But let's think about it here, okay? If I'm looking at, if I say I'm at B, okay, and let's just say, just imaginary, if I were to say, you guys can already say for me, rotate it, right? I'm gonna rotate, but not only am I gonna rotate it, right? You have to know like a clock, right? So what's the opposite again? Clockwise going from right all the way down to the left. So instead of going clockwise, going counterclockwise here, okay? So first thing you should know is like, okay, I can't clockwise this turn, I'm going counterclockwise this, okay? But now the question I always get, people always say is, how much? How much should I go? Should I just go like one thing, two things, maybe three, right? But think of it like this, okay? If you're at 0, 0 here, okay, this is 100%. You're halfway at 90, okay?
Halfway at 90 is gonna be right here, almost. I say, yeah, no, this is 190 right here. I was right. You got 180, then you got 270, 360 here. Okay. Again, you're thinking like a big circle here, right? So we're going counterclockwise. I'm going counter. Again, let me make sure I write this right. Again, I can't spell it well. I'm sorry about that. 270 degrees. Counterclockwise 270 degrees. Okay. Now, remember for our rules here. Okay. There's a couple ways you can do this, right? You can do the whole, again, you probably all learned this. You take a piece of paper, do a little turn, get there, right? You all know that one. Okay. I'm a rule guy because I'm lame. I don't have God rules. I don't know what to do here. Okay. So, the rule here, okay, like I said, if we were to get this to 90 degrees turn, just 180 actually, we did the 180. 180 for this is going to be -3, -5 here, okay, because opposite signs here, okay? If we were to get to 270, okay, and yeah, I was going to make sure I'm right here, because yeah, I don't know if I'll be right here. I think we're going to be at, let me guess this right, we're going to be at +5, -3, right, Ms. Condra? I'm assuming, right? We would rotate 270 if we use the rule for 270 degrees. Right, it'll be what? It'll be 5-3. Okay, awesome, good. Okay, so here we go. So two counterclockwise 273, which means for this, you just flip this here, okay? All we're gonna do is flip the points. So once we rotate B, which is at 3, 5, we rotate it, okay? We're gonna end up at a new point, which is gonna be 5 and 3. So I'm gonna get a different color real quick. 5 and 3, so 1, 2, 3, 4, 5, 1, 2, 3. So right now, this is where we're at, that red dot. That red dot represents 5, 3. Okay, again, 5, 3 represents the rotation at now, 270 degrees counterclockwise. So now, you're probably like, well, how you got the F? Because F right now, if you look at F, and again, this is on me, I should have wrote that in the beginning, right? Okay. F is located at, again, let me make sure I count, 1, 2, 3, 4. 1, 2, at 4, 2. Okay, so remember, you're at 5, 3. You need to get the 4, 2. Okay, we need to move this to F. So what's the transformation we use to move things? You probably all can probably guess it right now. It's gonna be translation, right? We're gonna slide it over, right? We need to slide this point around here, okay? We did our rotation, so now we need to slide here, okay? So again, I'm gonna make sure I show my marker here. Again, we rotate it right there, and we need to start and right there, right? So, how to look at this? We're gonna look at these 2 points right here. These are 2 points we're gonna look at right here. I'm gonna make sure I box this up too for y'all. 4, 2, and 5, 3. Okay? Now, the real question is, translation rule says this. You have X, okay? Now, I'm starting at 5. And I'm ending at 4, which means I go what? 5 to 4 is going down 1, right? So I gotta go X minus 1. Okay, actually, now I lied to you. Not bad. I'm getting all my words messed up there. Okay? 4 to 5 on the X axis, translation rule C. You just make no mistakes here. That's left to right movement, right? So from 5 to 4, I have to go to the left 1, right? So that's X minus 1. Okay? To get from 3 to 2 is going down 1. So that's Y minus 1. Okay, this will be our translation rule here, okay? So again, just for translation rule's sake that we go over it. Anytime you go up, okay, or down, okay? Anytime you go up or down is positive, negative for the y-axis, okay? Anytime you go to the right or left, positive, negative is for the x-axis. Okay, so that's how we determine what's what here, okay? To get from 5 from the x-axis to 4, went to the left 1. To get from 3 to 2 on the y-axis, went down 1. So x minus 1, y minus 1. Okay, so overall, your answer, if you were to take this as a question on your test, the answer you guys need to put here is the following, okay? You will say, again, it could be word anywhere, but you'll say counterclockwise, 270 degrees. Then translate 1 unit down and to the, and 1 unit down and 1 unit to the left.
Okay? And then again, you were to apply this to every other point, it'll all be the same rules to there, okay?
Question, what if they asked how to write that algebraically?
Explain more on that detail on that one.
So they'll write the rule, I should say.
Oh, okay, so they were actually write the rule more
See
algebraically.
that one over on the right?
Yep.
But then the whole thing, because they will see it like that.
Okay, so if I want
So
to,
first they do the,
so again, if I wanted to write this rule algebraically, right? Translation 1 unit down, 1 unit to the left. Okay, this is the rule algebraically, okay? Again, using your X and Y's here.
oh, I do. So,
Oh.
I'm gonna, am I in the?
Yeah.
Oh, God, I need to suck in. So the first thing you do is you do your rotation 270. So that, by the way, this is where you start, then you write the rule. So all that you do from here to here is you are switching the X and the Y. What was it, 3, 5, then it went to 5, 3. Then you have another box and you do the 1 unit down and 1 unit to the left. Very interesting with this because when we write this, we want to write that part first. So it's going to be X minus 1, comma, Y minus 1. So left, then down. And they will ask them to do that. So,
Okay.
and that's it.
All right.
Good job. Mr. Do you want to conclude?
Go.
Good.
Yep. All right.
Mr. Perez, this student supposed to be at A1.
Yeah.
Okay, so they're texting me where are they?
Oh, I got
There's a sign on there.
Yeah, here's the sign.
Thank you, everyone, for doing that. I'm sorry.
it. Dang, everyone. I
Yay.
got it. It's about that.
Woo.
Yeah,
Yay.
yay.
That's right.